Hello and welcome everybody. So today is the day 3 of our Smart 25 days challenge, and today we would be making a simple coin flip contract. Okay. So first of all we would be opening our Remix IDE and then clicking on the contracts as I have told you earlier also. Now clicking on create a new file on flip coinflip.sol. Okay, so what is a coin flip smart contract? It is a smart contract which resembles the flip of a coin. Okay, so we would try to create a smart contract which would resemble a real world scenario in which we would assume that we are flipping a coin. So first of all, as you would know, our first line is the SPDX license identifier. Then our second line is Pragma Solidity version. Yes. Don't need. And in this, we'll specify our compiler version that it would be working 0.8.0. Okay. So first of all, let us open our notes, and this is basically this is what we are going to create, and I have entered it into the notes. Okay, so how to approach solving the problem to create a coin flip smart contract. So this is the first and the foremost most important thing. And first of all, we should know that how we are going to approach this problem. And one more thing, we would be learning a few new concepts today, and one of them would be events, and we'll learn a few more. So, first of all, we should know how we are going to approach it. This is first and foremost point, that is understanding the requirements. Like, first of all, we should understand what our requirements are. So, first, you need to carefully read and understand the requirements of the game. In this case, the game is a flip coin where players can bet on the outcome, head or tails, and receive a payout if they win. Okay, so simple. Then identifying the key components. What are the key components? So these would be the key components. Player should be able to place bet. Okay, makes sense. The contract should generate a random outcome to determine the winner. The contract should track the balance of the contract. Uh, Basically, it means that as the people would be winning or as they lose the money, so our smart contract would keep the track of the balance it is containing. Okay, the smart contract contains a balance, and uh, the smart contract contains a balance, and I would show you how we are going to keep a track of it. Okay, the winnings should be transferred to the winner. This is the important point. The winnings should be transferred to the winner. That makes sense. And now the third step would be designing the contract structure. Okay, so what would be our contract structure with like what can be the state variables? We need to determine that key how we are going to design the structure of our contract, and if there are any functions needed, and if they are required. So basically, most probably they are required, and how many are required. So this, and then implementing the contract logic. So basically I have written down this just to make sure that even after if you make this, and even after so many days you go through this, so you can just remember all the points. Okay, so how I had approached this problem and how I had created this smart contract. So basically you can go through this for revision purpose also. So implementing the contract logic, hmm, and then testing and deployment makes sense. So now we let us move back to our Remix ID, and now let us start making the contract. That would be this one, contract and contract name would be coin flip only. coin flip, the file's name and the contract name. We basically make it same. It's a good practice. It is not at all required, but it's a good practice. So, first of all, as I said, that we need to define our state variables. Okay, so here we would be having two state variables. Two state variables means first we would be making a state variable for the owner of this contract. So basically, in this implementation, we do not actually require who is the owner require uh, uh, there is no actual requirement of knowing who is the owner of this smart contract, like who have deployed it. We can give some authority to the owner of the smart contract because it is required in some use cases. So we are gonna create a first of all owner state variable of the owner, and owner would be, how will we identify the owner? We will be going to identify the owner based on his address. Okay, so the address, so the data type would be address only. So address, and it would be public or private, you can declare it anything, but I would suggest, like, we are going to declare it as private only. OW owner. Then the other state variable would be the second state variable. That would be the second state variable would be the contract balance, because we need to keep track of the balance of the contract. Okay, so it would be uint 256 uint, then uint it should be public, and contract balance. Okay, makes sense. And then we need to now to see the implementation of events. Okay, so what are events in Solidity? So events in, what is an event in Solidity? Okay, so we'll see what is an event. An event is a way to emit and log specific occurrences or actions that happen within a contract. Events provide a way to communicate and store the important information about the contract's execution. So basically what it means is, event is something, you can assume that you are at a say concert. Okay, so in that concert you get to know about a few announcements. Okay, those announcements that you listen, those can be thought of as events. Okay, so the main use of event is that it makes it is like making the announcements. Okay, so it allows other people who are contracting us or who are contracting this smart contract to know about what are the happenings happening in this smart contract. Okay, so to inform them, we use the events. Okay, an event is a way to emit. Yeah, so the key points about events. Okay, so these are very important points. Okay, so as we are discovering something new each day, and today we would be learning about events in Solidity. Okay, so events are a way to emit and log. Okay, they allow contracts to communicate specific occurrences or state changes to external entities. Okay, and in the later upcoming days it would be more clear how they do it. Okay, but for today, this is today we would be just having a basic introduction about events. Okay, event are declared using the event keyword, makes sense, followed by a event name and its parameter. Okay, just like we may declare a function, we declare a event. Parameters specify the data to be logged when the event is emitted. The indexed keyword. Okay, so this is an important thing, and we'll see how helpful it is. The indexed keyword can be used to mark parameters for efficient filtering and searching. When we use the emit keyword, okay, so we declare an event by using an event keyword. Okay, and we log the details using the emit keyword. The emit keyword followed by the event name and its parameters within a Solidity contract. We use this emit keyword for emitting the event. This means we are triggering, you are triggering the execution of the event code, and we'll see what it means to be more clear. Okay, if don't get confused. When an event is emitted, the specified data is logged into the contract's event log. Okay, so it means that the when event is emitted, the specified data which we have specified at the time when we declared our event, when we were declaring the event by using the event keyword. At that time, we would be declaring some parameters, and after giving those parameters some value by using the emit keyword, and after assigning some values to those parameters, the event gets emitted, and the specified data is logged into the contract's event log. And this basically means that it becomes the part of the blockchain, and then we or anyone can see what the events happen. Okay, so events are basically for making some announcements, for making some special occurrences, for specifying that something special happened while the execution of this smart contract. Okay, so the emitted events themselves do not execute any specific code. Okay, events are publicly accessible, but the event data within the contract is not directly modifiable by external entities. It completely makes sense. It is just like you can hear the announcements, but you cannot change the content of those announcements in a concert. Like going back to our concert analogy only. So while you are at a concert, you can hear those announcements, but you cannot make changes. So the external entities cannot make changes to the events. Okay, but they can access them, publicly access them. Okay, events are primarily used for communication and logging purposes, and events emitting events do not consume gas. This is also an important point, that it, even if it consumes the gas, it is near about negligible. It is very less. Okay, so emitting events does not consume gas, and gas is only consumed when executing the contract code or performing state changes. Okay, so now we'll create an event and see what is the use of that event. Okay, so we'll create an event called coin flip to let everyone know that the flipping of the coin has happened. Okay, so the parameters that we would be assigning to this are, mm, and we are using this indexed keyword, and I will tell you why we are using this. And will result bool, sorry, bool result, and mm, 256 amount that we want, blue coin. So this by using the keyword event, we have defined our event. Okay, so the event definition and the name of the event would be coin flipped. Okay, and in that definition, we have specified the parameters that are uh, address data type player, like the address of the player who is playing. Okay, bool result, whether he won or lost, true or false. Okay, so true to be winning and false to be losing, or some we can define it in that manner. And un 256 to be amount won, like the amount which he want, and data type un 256. Okay, makes sense, no problem at all. Now let us move on to create and one more thing, we are, as I said, that the address, as we have defined that the owner. Okay, so how will we know who is the owner or who deployed this contract? So yesterday only I told you about something called the constructors. Okay, so a constructor is a special kind of here. The is a special function that is automatically executed during the contract's development process. It is used to initialize the contract's state variables or perform any setup tasks that need to be executed when the contract is created. This basically means that it is a one-time executing function, a special function which executes only one time, and it helps us to assign a few things. Like it, today, what we are going to do is constructor, and then constructor with, and we would be using a special keyword called message dot sender, and we would be assigning owner message dot sender's value to owner. Okay, what it means is, so first of all, you may ask, what is this message dot sender? This message dot sender specifies the address of the person who is calling that function or who is using this smart contract at that time. Okay, so we are saying that the constructor is a one-time executing function, as we know. So it would assign the person who will deploy it, that person's address would get stored in this message dot sender. This message dot sender will fetch that person's address and then assign it to owner. So we'll know who is the owner of this smart contract. Okay, so now we have also used constructor in our smart contract, and now we'll proceed by making a function called flip coin. Okay, so and we'll assign it the visibility as public and payable. Now we'll also see the use of payable today. As I have told you yesterday only, there are three state modifiers called view, pure, and payable. Okay, so yesterday I told you about view functions. Today today we would be seeing payable. Okay, state modifiers or function modifiers: view, pure, and payable. Payable enables the function to receive ether as a part of the function call. It allows the function to handle ether transfers, and we'll see how it happens. Okay, so what is an event? We have covered. What is the use of indexed keyword? Yes, so the index keyword is used to specify a particular parameter that should be included in the events index. Okay, by indexing a parameter, it becomes possible to efficiently search and filter events based on that parameter's value. Okay, it is basically used for indexing. As you use in the class, we use the roll numbers and all. So similarly here we use a index parameter. Okay, so it is not at all required, but it makes it easy to search later on. Okay, so we have what we have done is we have indexed the address of the player. Okay, we have used the address of the player for indexing in our event. Okay, so it completely makes sense, I guess. So now we'll move forward, and we would proceed by and I'll show you what this message dot value is. Okay, so don't worry, I'll show you what this message dot value is and how we send it, and we'll also talk about this require keyword. Okay, please send Samit, and mm, so we'll also see require the use of this require keyword, and in this function we declare two local variables u int 256 bet amount, like the amount which is being bet amount equals to message dot value, and one more variable we'll declare 2 int 2 u int 256 winnings equals to, currently initially it would be 0 only. Okay, so let us talk about this require index. We have talked about the index keyword is used to specify a particular parameter, and then let us I have told you about this message dot sender also. In Solidity, message dot sender is a predefined global variable that represents the address of the sender of the current function call. It refers to the account or contract that invoked the current function. Okay, so what is the use of require keyword? It is basically a requirement only. Okay, so that it we specify by using a require keyword that it is a mandatory requirement and we need that to be fulfilled. So The require keyword in Solidity is used to enforce certain conditions within a smart contract. It acts as a condition check and throws an exception if the condition is not met. Okay, so this is how it works. So now let's move back to our code. Okay, so till now what we have done is we have started creating a contract, and we have declared our state variables and then created an event, and we have also used constructor to define who would be the owner of the contract. And now we are creating the function flip coin, which is the most important function, okay, which will be doing all the tasks. By using this require keyword here, we have specified that the message dot values, like the person who is going to play the game, and the betting amount which he is keeping at stake should be greater than 0. Okay, and now we are using this. We are creating our temporary local variables. Okay, for this function, and in this uint 256 bet amount message dot value is would be the bet amount, and current winnings would be 0 initially. And now we would create a function to create a random number. Okay, function to generate a random number between what, 0 and 1. Why 0 and 1? Because we can think of 0 like head or 1 like tail, and or vice versa. Okay, so let me first write down the code and then I will explain how a random number is being generated here. U into 56 random number. This I hope you must be knowing. This is a camel case format. Okay, so I guess you all must be knowing this, that we are using the camel case convention. Okay, U into 256 and ABI dot code pckd block dot stamp, and then address message dot value sender message dot address of the sender, and we'll keep the modulo at 2. So now you must be wondering what I have done in this line. Okay, so in this single line, we would be able to generate a random number between 0 and 1. So what this is doing? Okay, so first of all, what is block dot timestamp and what is message dot sender? I have told you earlier. Okay, so this is the address of the person who would be using this function, or who is initiating this flip coin function. Okay, so, and block dot timestamp, oh, STAMP only, STAMP. Okay. So, what is ABI encode packed? I will, first let us talk about ABI encode packed only. Okay. What is this? What is this? ABI encode packed, what it does is it is a solidity function used to concatenate multiple values into a single byte array. Okay, here it combines the block.timestamp and message.sender into a single byte array, which can be used as the input for next steps. Okay, and so what is, first of all, let us talk about what is block.timestamp. In Solidity, block.timestamp is a global variable that represents the timestamp of the current block. It returns the Unix timestamp, the number of seconds that have been elapsed since January 1, 1970. What it means is, I can show you. If we just type block, so if you will just search block.timestamp converter, so it will open, and here you can see that these many seconds seconds since January 1, 1970. These many seconds have passed since January 1, 1970. And we would be using this block.timestamp a lot. So let's get back to our code. And so this makes it completely clear. Okay. It is commonly used for time-related calculations or for generating randomness by combining it with other variables. Okay, to create a unique seed for random number generation. And now get back to our code and see. Okay, so block.timestamp you must have understood, and this message.sender. Okay, so now what it is doing, it is making a single byte array of by combining these two values. Okay, and what this is keycack 256. This is just like SHA-256. This is based on SHA-3. This is a hashing algorithm. And why are we using KiCac 256? And can we use other algorithms like SHA-256 here to generate a random number? The reason we use KiCac 256, a variant of SHA-3 algorithm, is that it is widely used in the Ethereum community. Okay, so here it's written that while other cryptographic hash functions like SHA-256 could also be used, KiCac 256 is preferred choice in Solidity due to its adoption in Ethereum and its standardized use in the Ethereum virtual machine. It is it is widely supported by tools, libraries, smart contracts development and development frameworks. Okay, smart contract development frameworks. So now, and this what it does, it gives us a uint 256 of this whole thing. Okay, so and why are we are taking the modulo 2 because see if I give you any number, if I say I give you 15 and ask you to give me the modulo by 2, so it would be 1 because modulo gives us the remainder. So by if we do the modulo of any number by 2, it will give us either 0 or 1. So this is what we require here. Say 20 modulo 2 would be 0. So it is what our requirement here is, and that's why we are doing modulo 2. And now if now let us see how we can proceed further. So for proceeding further, we would be like if the random number is 0, the player wins. Okay, and so if say the random number which we get is 0, so we assume that the player wins because it is like assuming here say you are a referee and two of your friends one of your friend come to you and say ki you flip the coin and I would be calling for it. Okay, so here what we are doing is there that friend has has a choice whether he can call it to be head or tail. Here what we are doing is we are generating a random number which is completely random and which is not predictable. We cannot predict the outcome of it. But what we have kept is like in the real world scenario, say you are before flipping the coin you decide ki is you tell your friend that okay, say if head is there, if head comes then you win, if tail comes then you lose. Okay, so you are not giving your friend the choice to actually make the call. You are you have predefined it, and the flipping of the coin is completely random. Okay, it can go either way, but now what you have done is you have uh, made it as a final decision that okay, if it comes head then you win and if it comes tail then it lose. Okay, now we have what we have we are going to do is we would be uh, keeping the fixed value like if it is 0 then the player wins and if it's 1 the player loses. Okay, so what we can we are going to create here is bool player wins. Okay, and if he wins then so this would be a simple logic. We are just going to use if and else here. If random random number random number equals to 0, this is the comparison operator, equals to 0, then player player wins equals true. Okay, and else player wins equals to false. Okay, this makes sense. Now we would be like, we now we are going to make a condition for the transfer of money. Okay, transfer of some ether if the player wins. Okay, if player wins. So if player wins as this player wins is a boolean. Okay, either true or false. So basically what it means is, if true. Okay, if true, then do what you do, winnings equals to the winnings here. These winnings make them as bet amount into 2. Say we say the amount which you have betted, you get twice of that amount if you win it. Okay, and now payable message dot sender dot transfer winnings. So what this line will do, this payable keyword is making the address of the player. Message.sender here is the player, okay, which is calling this function flip coin, okay, and that player's address, this payable makes it able to receive the cryptocurrency, okay, as we know what payable keyword does. And this transfer is a function which transfers the amount, this winnings, winnings, these winnings to the account, this account. Okay, so this transfer is a keyword, is a function which transfers this amount into this account. Okay, makes it clear. And then we can say make the contract balance. Okay, we are keeping a track of the contract balance also. Contract balance equals to bet amount. We would reduce the betted amount from here. So then let's come to the else part. Else contract balance gets increased by the amount which the player betted. Okay, so you may ask ki, Jay, here this is incorrect because the contract balance should be deducted with the winnings. Okay, that should be bet amount into 2. But actually think of it, actually the amount which would be deducted from the contract would be betted amount only. Why? Because say, if you are betting 2 rupees, okay, and I'll pay you the double of 2, okay, if you win, and say the player wins it, so we give him 4, but actually from our side we give only 2 rupees. The 2 rupees he was actually in the initially also having, and he staked them, and after staking them, what we did, we played this flipping a coin game, and after if he wins, then from our side we give 2 rupees only, and the rest 2 were his only. Okay, so what it does, what it means is, from the contracts balance only the betted amount would get deducted. Okay, not the winnings amount, because he is technically winning 4 rupees, but actually he is getting only 2 rupees from our side on winning, because the amount which he staked, we are promising him as a 100% return on that. Okay, so you would get the same amount from our side if you win, and yours is yours only. So from our side we have to go give only 2 rupees if he is taking 2 rupees. If he is taking 4 rupees, then from our side we need to give only 4 rupees, not 8 rupees. Actually, technically he is getting 8, because, but actually 4 were his only, and from our side we need to give deduct 4. Okay, I guess it makes it clear what I'm trying to say. And now here is a very important part, that is we need to emit the event. Okay, this event which we had created, this event, this here we have declared it, but now we need to emit it, ki tell others ki now the coin has been flipped. Okay, and the values for these parameters, the arguments, the values would be message dot sender player wins, matlab either he is winning or losing, true or false, and winnings, the amount which technically he is getting. Okay, so you can see address here, then bool here, boolean here, and then winnings is the UN 256 amount won. Okay, amount won would be winnings, these winnings. Okay, I guess it makes clear. These are the parameters which we had specified, and now we are passing the values, the arguments. Okay, and this basically this is not a function. Yes, this is we are generating a random number between 0 and 1. Okay, so why is it extra? Okay, let us try to compile it if it gets compiled successfully. Yes. Okay. Makes sense. We have compiled it. Now we'll try to deploy it. Okay. So the address by which we'll deploy it here, it is this one. Okay. So this will be acting as the owner, owner of this smart contract. Okay. See, we had not given any value, and it has been successfully deployed, because the owner does not require to provide any value here, this message dot value, this is the value which we'll provide here, and it can be in way, gray, finny, or ether. These are small amounts, and we'll discuss about them later on, but now you can see we'll be say, and now some other account wants to play this game. Okay, so now if he tries to play this game, okay, now you can see this uh, contract has been deployed, our contract has been deployed, and without passing a value, say this is a person. Okay, these assume them to be some 10 15 players. Okay, 10 15 persons, different persons. Okay, these are having different accounts, and these are the different accounts with of different persons. Okay, assume them. And now if this person passes nothing here, so when he will try to flip the coin, it will not get executed. Okay, because he has not given any value. And now if he says that I am willing to stake 1 ether and then try to flip a coin, then it gets executed. Now you can see, but he lost. Okay, the result came out to be false. So now let us try with some other person and see if he wins or loses. So we'll stake only 1 ether and flip a coin. He also lost, because we can see the balance of the contract. You may or may not have noticed that this balance, this is has been shown from the beginning in our hello world contract. Also remix showed us this balance as 0 ETH, because there was no uh, transactions happening there. And in our simple storage contract also, this balance was already there, but we cannot communicate with the front end using this balance. So we have created a contract balance, this contract balance, state variable. Okay, and we, as we have created it, we have kept it its visibility as public, so we have already got a what a getter function for this. And you may wonder what this large value is. This value is actually the ethers only, but in the currency, in the way amount. Okay, so one way is 10 to the power 1 ETH equals to 10 to the power 18 way. Okay, so you can search. So you can search 1 ETH to way, and you will find it here. The smallest unit of ETH is called a wave, which is equivalent to 10 to the power of minus 18 ETH, which basically means that ETH is equals to 10 to the power 18 way. Okay, so let's come back here, and we'll try to just play this game with some other guy. And now if he tries with 1 ETH, and so, oh, sorry, I made it way. So this guy actually won something, but true. See, because some value got deducted from our contract. Okay, so but yeah, this guy got only one way. No problem. And now let us try with some other person and try to play this game again. So this guy also lost. I don't know why these all people are losing this. So this guy also lost. So now this guy won. Okay. So you can see that only one ETH got deducted from our balance. Okay. Not we this person technically won two two ETH, but the amount which got deducted from our side will be one ETH only, because one was his own only. Okay. So you can see the amount. So that's it for today, and let us move on back to our notes. So why is it so difficult to generate a random number in Solidity, and why is there no inbuilt function to generate a random number? So these are basically these are the three factors because of which a random number cannot be generated by using a inbuilt function. There is no inbuilt function to generate a random number. Okay, deterministic execution, consensus and validation, and security risks. So that's all for today. I guess you guys must have learned something, and if you guys have any uh, doubts or any problem, you can ask me in the comment section, and I would be more than happy to resolve them.